Good morning, students. The next topic of discussion is recurrent neural networks. We have studied about neural networks, which are known as artificial neural networks. And then we have studied about convolutional neural networks. The third type of architecture related to neural networks is a recurrent neural network. This mainly belongs to machine learning category, and these two belongs to deep learning. A recurrent neural network, like a normal neural network made up of neurons that have learnable weights and biases. The significant feature of recurrent neural network is that it maintains a memory over time, and therefore it is mainly used for modeling sequences or time series data. So essentially any function involving recurrence. What do you mean by recurrence? Uh, it must remember the state, and it must uh, create a sequence or series based on the previous state. That is recurrent neural network. Here, recurrent neural network are a family of neural networks for processing sequential data. Convolutional neural network is a class of neural network for processing image data. All right, try to understand the difference. Recurrent is for sequential data and concurrent is for image data. And how this is implementing this functionality? Through parameter sharing. And network remembers a specific piece of information, xt, that occurs in sequence for each new output is a function of the previous value. Let me give you architecture. A normal neural network will have input layer. Say there are two neurons in the input layer, and hidden layers. Say there are three neurons in the hidden layer, and output layer. Consider that there is one single neuron. The architecture looks like this. Each neuron is connected to all the other neurons in the subsequent layer. This neuron 1 is connected to all the three. This neuron 2 is connected to all the three. And these three hidden layers are connected with the output layer. This is a neural network architecture. How is a recurrent neural architecture looks like? It has got input, all right. It has also got a hidden layer and output layer. The difference being here, hidden layer is connected to itself. This can be generalized in the format which I will tell you now. Okay, if you observe here, you have this connection which is coming from itself. This can also be depicted in this manner. You have a normal neural network where you have this output which is connected by the hidden layer and connected by input. And then RNN layer has the output, has a hidden layer and an input. Observe here that this hidden layer has a connection to itself. Whatever was shown in the earlier diagram, same thing is here. And this thing can be expanded for multiple layers. How it is done? You have Y naught coming from H naught from X naught, where X naught is input, or this is input layer. This one is this is input layer, this is hidden layer, and this one is output layer. There can be multiple outputs. There can be multiple inputs, right? And likewise, you can have a multiple hidden layers. You see here, hidden layer H naught is connected to H1 because this is a group. All the hidden layers operate in the form of a group and they share, this is y of t minus 1, h of t minus 1 and x of t minus 1. Here these three hidden layers they share the same weights and biases. This is the architecture of recurrent neural network. Let us consider the motivation. Why a recurrent neural network is needed when there are architectures like uh, CNN or ANN. What is the motivation for having RNN? The motivation is motivation for RNN. First one, CNN, convolutional neural network, accept only fixed size input. For example, MNIST data set. The size is 28 by 28. This is a grid, right? You have 28 rows and 28 columns. Here this is 28 and these columns and these rows also 28. So you have 28 by 28. Every image in that MNIST data set is of same size with the dimension 28 by 28 by 1, where 1 signifies uh, the uh, the dimension which state whether the image is in a color image or black and white image. If you have 28 by 28 by 1, this one denotes that it is a black and white image. If you have 28 by 28 by 3, these are the three channels: red, green, and blue, RGB. Because every color is formed from different portions of red, green, and blue. That's why you have three different channels. It's known as channel, and three channels denote these three colors essentially. So apparently here you can see that you have same dimensions or same size for every image. That is CNN. Second one, CNN cannot remember long-term dependencies. What do you mean by long-term dependencies? Let me give you an example. When I am speaking to Google Assistant, I say, hey Google, then it starts. Then I have posed a question. This is my question. What is coronavirus? When I asked Google what is coronavirus, this question, this Google Assistant has given this answer. Coronavirus disease, COVID-19 is an infectious disease and all. Next, immediately in the same session of interaction with Google Assistant, I asked Google, where was it started? What is the meaning of it here? What is the meaning of it? It is pointing to what? Can you tell me it is pointing to what? Because I asked the question, my first question was what is coronavirus? Then my second question was, where was it started? You see here, this it is referring to this coronavirus or COVID. And in the same interactive session, the subsequent question that I posed to the Google Assistant, oh, so I did not take a screenshot of that perhaps. But then I asked the third question, these are the screenshots of my interaction. Just before the class, I have asked Google about this. So, is there any vaccine? I asked, is there any vaccine for it? When I asked, is there any vaccine for it? What Google does was, Google gave me answer related to this COVID-19 only. Why? Why is it relating it with this subject? This is the subject which I am discussing, right? So why is it relating it with the subject? Because it understands and it remembers. How does it understand? Because it is remembering. What it is remembering? The first question. It remembers first question, and then when I ask second question, it relate the second question with the first question. So there is a dependency here. And third question again is dependent on this first question. Likewise, I can go on asking questions. Uh, Let us say 10th question is also related to the same subject which was asked in the question 1. What is it? This is nothing but long-term dependency. This long-term dependency is not preserved in CNN, whereas you find this long-term dependency in RNN. All right. Another example to state another example is about sequence, number sequence. Let us consider two numbers, two series of numbers. Series 1 is having numbers 10, 11, 12, and this is the question mark. Now, a system should predict. And number 2, you have 4, 8, 12, and this system should predict. What is system predicting in this case? And what is system predicting in this case? Can you make a guess? This here, the output will be 13. Why it is 13? Because it knows that it is just counting and incrementing by 1. 13 from why 13 is the output, because it is dependent on 12, its previous output, and 12 is dependent on its previous output 11, and 11 is dependent on its previous output 10. So here you see that there is a chain and all are not independent. They have some kind of correlation. Here you can see the output might be 16. Why it is 16? Essentially because here you are adding plus 4. Here it is just plus 1. Here the pattern is plus 1 to the present number. What is the present number? 10. You add plus 1, it gets 11. And now what is the present number? 11. You add 1 to it and it gets 12. Uh, Here what is the pattern in the second series? It is plus 4. When you have a pattern plus 4 and the starting number is 4, 4 plus 4 would give 8. That's why you got 8. And how you got 8? Because of its previous value plus 4. And how this 12 is given? Because of its previous output 8 plus 4. Therefore, you get 16 because 12 plus 4 is 16. This kind of dependency and correlation is what recurrent neural networks uh, works with, solves the problem related to this type of data. Whereas this thing you oh, all right. The model, recurrent neural network model, can be arranged in various forms. You have one to one. In this one to one form, this is nothing but architecture types. One to one means there is one input X, there is one output Y, and there is this hidden layer H. This is one to one arrangement. Then you can have one to many. In this one to many, you will have only single input and several outputs, many outputs. Let us consider that there are three outputs, Y0, Y1, Y2. Here you have H0, H1, H2. So X to H0, H0 to Y, and this present state is given as input to the next state because it has to remember, and then it gives output and it passes the same value to the succeeding layer and it gives the output. This is one to many. The application of this one to many is image captioning. What do you mean by image captioning? If you give an image in which there is a guy with a football, okay, so the model automatically, uh, our neural networks must give a caption to this. When you post an image on Instagram you might give a caption like that. A human is not giving the caption, rather the machine, the model would suggest a caption for this image. Model may say that a boy with football, a boy is playing football, or a football player mm, with a football. Like different captions you can have for one particular image. Okay, so these captions are not specified by the human, rather it is given by the recurrent neural network. All right, this is the application of one to many. In one to many, this is the image. The input is the input would be the image. Output would be the caption. If in this case you can have more 1, 2, 3, 4, 5 more two nodes, and then you have another type which is many to one. In many to one, at input side you have multiple inputs x0, x1, x2, and you have hidden units h0, h1, h2, and you have only one output y. Here you see x0 is connected to h0, and h0 provides the output to the succeeding node, x1 to h1 and h1 to h2, x2 to h2. And from h2, it has got the context. How does it get the context? It knows its previous value, which is h1. h1 knows its previous value, which is h0, and therefore h2 knows about h1 and h0. And if you have like this multiple hidden nodes, say 100 hidden nodes, you perform the similar thing. Each one is connected to the succeeding one. Here the application would be, this is image captioning. Here the application would be stock prediction. What happens in stock prediction? At different time, xt plus 1, xt plus 2, stock has got some value that each one is feeded into the network, and finally what will be the value of it of that particular stock, which was having all these values earlier to this. If I take this as t plus 1, this would be t, this would be t minus 1, this would be t minus 2. So what would be the value at t plus 1? Okay, and you are specifying all the previous earlier values. This is input, stock price, different prices at different time. Here you want the stock price at time t plus 1. So the model studies and learns from all these previous prices and uh, gives out the predicted price, the next price. This is many to one. And finally, the last type is many to many. This many to many model, there are many inputs and there are many outputs. X naught, X1, X2, H naught, H1, H2. This is Y naught, Y1, Y2. You have many inputs and there are many outputs. The application of this type is automatic language translation. Suppose you have a sentence in Hindi language. लड़का खेल रहा है. This automatically should be converted to English language. Say, the boy is playing. So what is happening here? Here you are giving this as input and you are obtaining this as the output. So this is automatic language translation. Okay, students, we studied about recurrent neural network, its motivation and examples and architectures, types. So tomorrow we will continue. Any doubt? Okay, then bye.